Hello and welcome back to the channel. Today we are going to start with descriptive statistics in R. Firstly, let's quickly have a brief introduction to what descriptive statistics is. So descriptive statistics focuses on summarizing and organizing data through measures of central tendency, dispersion, and shape of distribution. So there are basically three types of descriptive statistics. The first ones come under measures of central tendency, that are mean, median, and mode. Then measures of dispersion, that comprises of variance, standard deviation, range, and IQR. Lastly is data distribution, that deals with skewness and kurtosis. The first one to discuss is measures of central tendency. They tell us where the center of the data lies. So the first measure is mean, that is the average. The mean is the sum of all the values divided by the number of values. So the formula of mean can be mean equals summation x, that is the sum of all the values divided by total number of values n. If we take example of mean in R, we can just simply have any data variable having a list of some elements, let's say from 10 to 100. And for calculating mean, firstly we will have a variable named mean value, and in that we will call up the mean function that has the value of data. Finally, we will print this mean value variable. So the output of this will be the mean of all these terms from 1 to 100. It will be 55. So this function is responsible for computing the average value, and it is very sensitive to outliers and extreme values. Next is median. Median is the middle value when the data is sorted. Simply, if you want to calculate in the same data set, instead of the mean function, we can add on the median function and pass on the value of data to it, and finally print the variable storing this value. The output of this will be 55 only for the same data set from 10 to 100 if we consider. So if the data has even numbers, median is the average of two middle values and it is not affected by outliers, unlike mean. And if odd number of values are there in the data set, so the mean is simply total number of values divided by 2. Else for even as said, it is the average of the sum of two middle values. Next is mode. The mode is the most frequently occurring value in our data set, and R does not have a built-in function for mode, so we have to do it manually only. So this section of code tells us how we can calculate mode in R. This function finds the most frequently occurring value in the data set. These are the sample data set and the output value for the function to calculate mode. And mode is useful for categorical data. For example, if we are just trying to clean our data set based on gender or any particular category that we are working with. Moving on to measures of dispersion. So dispersion tells us how spread out the data is. The first measure is range. The range is the difference between the maximum and the minimum value. Simply, if we want to calculate range of a dataset in R, we will start by declaring a variable range value, and into that we will pass on the values of max data subtracted by min data, and finally we can print this variable and we can get the range of that dataset. So high range means that there is more variability in our dataset and it doesn't show detailed distribution, and range is very easily affected by outliers. Next is variance and standard deviation. So variance measures the spread of data points from the mean, and standard deviation is simply the square root of the variance. So formula for variance here can be variance equals summation x minus x bar square divided by n, where x is our actual value, x bar is the mean, and n is the total number of values we have in our data set. For calculating variance, we use the var function in R, and for standard deviation, we have the SD function in R. So simply the var data function measures the spread of the data, and the st data function tells us how much data deviates from the mean. And lower standard deviation means data is closer to the mean, and higher standard deviation means data is more spread out. Next one is interquartile range or IQR. So IQR measures the spread of the middle 50% of the data. The formula for IQR is IQR equals Q3 minus Q1. And in R, we have a simple function, IQR data, to calculate the IQR of any given data set. It is not affected by outliers and widely used in box plot to identify outliers if present in the data. The last type of descriptive statistics is data distribution. The first one into this is skewness. So skewness tells us whether data is symmetrically distributed or skewed. Skewed means shifted to one side. So we have types of skewness to determine the data distribution. First one is if skewness is greater than 0. That means the data is right skewed. Skewness less than 0 means data is left skewed. Lastly, skewness equals to 0 means there is symmetrical distribution of data. For calculating the skewness, we need the library named moments. We can say we need the package moments for calculating skewness of the data, and skewness function is used and the data set is passed to it. Similar to others variable is there, then we finally print the variable to get the skewness. So skewness data, our function is, as its name suggests, computes the skewness value. If right skewed, so if we say our skewness is greater than 0 and our data is right skewed, so it says that mean is greater than median. And if it is left skewed, then mean is less than median. And if we take example of both of these cases, in this case it can be income distribution, and for left skewness we can have exam scores as an example. Next is kurtosis, that is peakness of distribution, we can say. Kurtosis measures whether data has heavy or light tails. So again, there are three types of kurtosis. The first one, where kurtosis is greater than 3, that is heavy tails, more outliers. And if it is less than 3, then light tails or less extreme values are present. And if it is equal to 3, normal distribution of data is seen in the dataset. Simply, we have the kurtosis function in R to calculate it for any given data set. It measures the peakness and outliers in the data and helps in determine whether extreme values are common or rare in the dataset. Last topic is visualizing descriptive statistics. We had covered data visualization in R, so it is quite similar to that. First one is histogram that visualizes data distribution, and this is the basic syntax that you can use. Then it comes to box plot that identifies outliers using IQR. This is what you can use. Last, we have density plot. It shows smooth distribution curve. And this is how you can use it. So, in conclusion of this video, you can just understand that descriptive statistics is of three types: measures of central tendency, measures of data spread, and shape of data distribution. And lastly, you can have graphical representation of each of the data that you want. So in the next part, we will explore inferential statistics covering hypothesis testing, confidence intervals, and p-values in R. So if you found this video helpful, do give it a like, share, and subscribe to the channel to help us grow. And I will see you in the next one. Till then, happy learning.